Hello everyone, welcome to our channel. In this video, we are going to learn about LangGraph in few minutes. So let's get started. So let's understand first why LangChain and why LangGraph then. Okay. So LangChain, when it comes to solve the problem of interaction with the LLM, interaction with LLM gets things done. Okay. So it gives us a provision of creating a chain. By a chain means we can simply supply the prompt LLM parser and gets the work done. Okay. It also gives us the chaining concept across the chain 1, chain 2, chain 3 can be connected together and we can get the things done. So what is the problem in that case? So it says that, okay, you need to manage the state of each chain yourself. We are not responsible for managing anything. There is no graph modeling. There is nothing like that in LangChain. For simplest workflow, you can make use of LangChain. But if you want to want to have the complex workflow, if you want to build up a AI agentic flow, then you should go with the LangGraph. Okay. So what comes in the LangGraph? So centralized state management, which is missing in LangChain. So every chain needs to have a state, but in case of LangGraph, we first create the state at the center of centralized state, basically, which is across the solution, and then every other node is going to read value from the state, manipulate the state, etc. Okay, so entire conversation, maybe one agent talk to another agent. So we can have a centralized state where we know what is happening across the nodes, and we can definitely see through it, debug it properly, and also the workflow can be managed easily. Okay, so what are the key components of LangGraph? State, graph itself, state, node, edge, and conditional edges. They are the key components of LangGraph. Let's quickly walk through it. First, we define the state, which is nothing but a type dictionary. Recommendation is type dictionary. It can be list or a string. And then we create a node. Node is nothing but a Python function which takes the state as an argument and return the new state, slice of a state or the completely same state. Okay, it depends upon how we are coding it. Okay, and then conditional edges. Edges are used to connect the nodes together. And then conditional edges, if you want to switch, okay, you need to decide which node to go from one node to another node, then we can make use of the conditional edge. It is equivalent to if and else condition. Okay, but it is written in a function. Okay, now let's see how this all three diagram. So here in the first, start and end is supplied by LangGraph itself. They are the nodes as well. So we taken the start and end from the LangGraph, connects it with the function that we define as a node and with the help of edge. Okay, in the second diagram, node 1 is connected to node 2 and finally to end. This is linear flow basically. And then we have the conditional edge example where we are making use of a small function which acts as a router which takes in node 2 to node 3, otherwise node 5. So this function basically returns node name as a string. So the function returns node 3 in double quote or node 5 in double quote, basically the name of the node, accordingly it function. Now what comes in the command? If the node 2 itself wants to route to node 3 without using the conditional edge, then in that case we use command. If we want to take the input from the end user, we can make use of the input or the interrupt. Okay, we'll cover difference between input and interrupt in the upcoming video. And the send is like this particular conditional edge is actually returning only the node name. So instead of returning the node name only, we can make use of the send function to actually send return the node name along with the state change. Okay, so both of this, if you want to do, then we make use of the send function. Check pointer is used to actually take in the state snapshot basically, because in each node we are manipulating the state. So if you need to take the snapshot of a state, then we have to use the check pointer. Okay, so memory saver is a class that gives us the capability of check pointer. So I've covered up a brief about everything in this particular talk. Okay, so let's quickly understand the LangGraph code flow. We first declare the state, as I talked about, key value pair, dictionary pair, and then we initialize the graph. This is what I'm covering over here on the right hand side. We first create the canvas and we create the state, and then we create the node, then connects the dots. Okay, so first we declare this and then we initialize it with the state graph, passing the state, and then we define the node, which is basically functions having the signature. The first argument needs to be state only, and the second is config. Like if you want to pass in some configuration to it, like the model name, etc. in case of LLM interaction, and then it has to return the new state, a slice of a state. This is what the node is. And then we have to make use of the add node function to add the node into the graph. And the add edge function is used to connect the two nodes, start to n1, n1 to end. That is how the graph is created. And finally, we will compile the graph and then we invoke the graph with the input. The input should be a state or a slice of a state, etc. So this will be passed to the functions, whichever is invoked in the node, etc. So whatever is the input here, it will pass on this basis on the graph workflow. Okay, so this is the brief overview of the LangGraph code flow. Okay, so if you understand this thing, then every other code you can write it out, whether it is complex or simple. So you can write it out. The only thing will change is number of nodes, and how you connect the nodes, whether edges or conditional edge, etc. Okay, and let's see the example. So we are going to cover up this example, which says that, okay, there is a start node which is provided by LangGraph itself. Then we will have a node analyze string. It will take the user input as a string and analyze the string whether it is containing a digit or not. If it contains a digit, it is an invalid string. It hold down to display failure. Okay, and then otherwise it will go reverse the string, display the output, and finally go to the end node. Okay, and in this particular area we will have a conditional edge function which will decide whether to return reverse string as a string or display failure node name as a string. Okay, and then this is the basic example where we are going to use chatbot talking to LLM. Okay, let's go to the VS Code, taking the example 1 in action. Okay, so what is the setup here? We are using UV package manager. You can check out our old video on the topic of UV. So to understand what is UV, what all commands we should use, you don't have to use explicit Python related packages if you are using UV. Okay, so we have used UV init command and then written up the code. We did the notebook setup in the VS Code with the help of UV, and you can obviously watch out the video. And what we are doing here, we are simply importing the statements. So LangGraph supplies start and state graph, right? So we just importing this in this statement, and then we are making use of the display image display just for creating the graph illustration within the command. Okay, within the prompt. Okay. So this is what the state is. We have the input output as a string is input valid as a which checks whether checks whether the input is valid or not, and accordingly we are initializing it. Then initializing the graph as I talked about, and this is the analyze string function which simply setting up is input valid as true or false basis on whether the string is containing a digit or not. Okay, and then we have this conditional router function which returns the node name as a string. This is what I was talking about, conditional edge. Okay, and then this literal is actually controlling the data type, controlling the possible values coming out of the function. Okay, so it can be 2 or more than 2 basis on what you want to return from here. And then we are having a reverse string which is simply taking in the state as I talked about. This is mandatory state. It takes the state, manipulate the state, and returning the slice of a state. In this case, state output colon this particular thing is a slice of a state it returns. Okay, and then these are the other functions. So if you look into this state is not being used, but still we are using it. This is mandatory because if we are associating it as a node, the passing a state is mandatory. Otherwise, it will show the compiler error. Okay. And here we are making use of the add node to add all the nodes into the graph, and then finally making use of the add edge. And add conditional edge is important. Here we are passing in the node name as the first argument, and then the conditional router function as the second argument, which returns the other nodes as a node name as a string. Okay, and then we are compiling the graph, and then we are invoking the graph with the input. Okay, so let's run this program. If I type in this play button and then quickly execute it, and then this is the positive case where simply it will do the reverse of a string, and it shows the reverse of a string. Suppose I am putting in the digit here, and then I am just executing it again. Okay, in this case it will not be reversing it. It's simply printing the input again and saying that is input valid is false. Okay, so this is all about this example particularly, and this is illustration of the image which you can draw with the help of display. This particular code is present in the Learn for Turkey repository, and the link is present in the link description. Okay, in the description, in the description section. Okay, so let's talk about the other example, which is very simple chat example. Again, we are doing the same import statements over here. In this case, this is what the example we are covering. We have only one node which talks to LLM. This is what the simplest example you have created using the LangChain, right? Talking to LLM, very simple example. The only thing is that we are making use of the Amazon Bedrock Nova Lit as a chat API. Okay, and the LLM basically here the node chatbot node is taking the state as a parameter. Let me just talk about important thing is here we are creating a state with the messages as an argument. Here the messages, here the state is nothing but a list. Okay, and this is add edges basically is a reducer function in case of LangGraph. LangGraph says that if you are not using it by default, whenever you return a state slice from a node, it will override it automatically, override anything present. But if you want to change the behavior of that override, if you want to continuously add a like if you want to continuously add something, in this case we are using add messages function provided by LangGraph itself. So what it does, whenever it returns this particular block, messages colon this, so instead of overriding this messages key value, it will simply append the additional message. So this is what the recommendation by LangGraph itself. So in case if you want to override the behavior of state manipulation, that you making use of the reducer function, we will take up a dedicated video about this. Okay. And what it does, basically we are simply adding this particular chatbot and then connecting the dots, start chatbot to add, and with the help of add edge function, and then compiling the graph and passing in the input. Here we are invoking it with the messages array, and then we are passing the role, user, and content. Okay. As soon as it passes, it will invoke this function, because this is the only node we have in this graph. It invoke it. LLM.invoke will invoke this this particular message. It will collect the response from the LLM, and then we are simply returning this as a state change. It will store this into the messages array. Okay, because here we are making use of the add messages provided by the LangGraph, and then we are printing it directly. I have already executed this particular flow, so instead of like investing time in it, so this is what the simplest example in the LangGraph. I hope you understand the basic concepts of LangGraph in a few minutes. So we'll see you in the next video, and we'll cover up all the topics of LangGraph in much detail, in much every other thing in the LangGraph, AI agent, etc. So stay tuned to our channel. Those who are new to this channel, please subscribe to this channel, and till then, bye bye.